All right, let's get right into it. If you've ever wanted to cut through the noise and actually learn how to build AI models yourself, then you are in exactly the right place. We're about to break down everything you need to know to get started.
Look, our goal today is simple. We're giving you the complete blueprint. This isn't just theory. By the end of this, you'll have the practical steps to build, train, deploy, and dominate with your own AI.
Because that's what this is all about, right? We're moving past just talking about AI. Today is about turning you into a builder.
Every great project starts with a rock-solid foundation. So, first things first, let's nail down the absolute core. What is artificial intelligence really?
At its heart, AI is just about getting machines to do things that would normally take a human brain. It's all built on a mix of a few key ingredients: tons of data, some clever math, a lot of programming, the models themselves, and of course, a whole lot of computing power.
Now, AI isn't just one giant thing. To build anything cool, you need to know the different tools in the toolbox. Think of these as the main weapons in your arsenal.
Okay, first up is machine learning, or ML. This is really the engine of almost all modern AI. It's where machines learn straight from data. So with supervised learning, you're basically showing it flashcards. You give it a million pictures labeled dog, and eventually it learns what a dog looks like. With unsupervised learning, you just dump a bunch of data on it and say, find something interesting. It might discover patterns on its own, like grouping your customers into different buying habits. And then there's reinforcement learning, which is all about trial and error. It's like teaching an AI to play a game by giving it a reward every time it makes a good move.
So if machine learning is the engine, then deep learning is the V12 twin-turbo upgrade. It's a super powerful type of ML that uses these complex structures called neural networks, which are kind of inspired by how our own brains are wired. This is the heavy-duty tech that powers the most amazing AI you see today. We're talking ChatGPT, self-driving cars, all that good stuff.
And to round out our arsenal, you've got these three. Natural language processing, or NLP, gives AI the power to understand and speak our language. Computer vision, or CV, gives AI eyes, letting it see and interpret images and videos. And then you have generative AI. This is the creative genius. It's the AI that can actually create brand new things like text, art, or even code.
So we know the different types of AI. But how does a model actually learn? I promise you, it's not magic. There's a blueprint, a clear process for how it goes from knowing absolutely nothing to making smart predictions. Let's decode it.
It all goes down inside what's called a neural network. First, you feed data, say an image of a cat, into the input layer. That data then flows through these hidden layers, where thousands of tiny digital neurons perform a bunch of calculations to spot patterns. Finally, the output layer spits out the answer, like the word cat. But here's the cool part. The real learning happens when the network gets it wrong. It feels that error and then adjusts all the little connections between its neurons to make a better guess the next time around.
Now, you use different tools for different jobs, right? CNNs are the masters of anything visual. They're perfect for image recognition. RNNs are built for sequences, so they're great at understanding the order and context in a sentence. But the absolute game changer, the one you have to know, is the transformer. This is the architecture that powers models like ChatGPT. Its secret sauce is that it can look at a whole chunk of text and figure out which words are the most important no matter where they are in the sentence. Honestly, understanding transformers is the key to understanding modern AI, period.
All right, here we go. This is the main quest. Let's put the theory on pause for a minute because this is the practical, step-by-step roadmap for building your very own AI model from the ground up.
The journey starts right here. Step 1. Pick your mission. Are you building an AI for text, for images, for security? Step 2. Get your data. Data is the fuel for your AI, so you got to collect it. Step 3. Pre-process. Raw data is messy. You have to clean it, organize it, and get it ready for training. And step 4. Select your model. Based on your mission, you pick the right architecture for the job. A CNN, a transformer, you name it.
And now for the action. Step 5. You train the model using a framework like PyTorch or TensorFlow to do the heavy lifting. Step 6 is all about evaluation. You gotta test your model to see how well it actually performs. Step 7 is deployment. This is where you release your model into the wild so people can actually use it. And finally, step 8 is to fine-tune and optimize. Use special techniques to make your model faster and more efficient. And that's it. That's the whole life cycle, from a simple idea to a real working AI.
Okay, if you're going to be a builder, you've got to speak the language. So this next part is a rapid-fire dictionary. We're going to arm you with the must-know terms so you can walk into any room and talk about AI like you own the place.
Let's start with the absolute basics. LLM just stands for Large Language Model. Think GPT-4. You train it on a dataset, which is just a big collection of data. From that data, the model learns to identify important features, like, say, specific words or pixel patterns. And the label? That's just the correct answer that the model is trying to guess. Simple.
So during training, when your model goes through your entire dataset one time, that's called an epoch. The batch size is just how many pieces of data it looks at in one single step. Now, loss is a super important one. It's just a number that tells you how wrong the model is. The lower, the better. And backpropagation, that's the magic process where the network uses that loss score to go back and tweak its own wiring to get better for the next try.
Okay, let's look under the hood of the model itself. To work with things like words, a model first has to turn them into a list of numbers. That's called an embedding. A transformer model uses a special trick called attention to figure out which words in a sentence are most important. And all those little internal dials that the model tunes during training, those are called its parameters. And finally, a few advanced terms you'll hear all the time. Zero shot is when an AI can do a task it was never explicitly trained for. Pretty cool, right? RAG is a way to give an LLM access to fresh, external knowledge, so it's not stuck in the past. RLHF is a training technique that uses real human feedback to make an AI more helpful and less, well, weird. And a vector database is just a special kind of database built to store and search through all those embeddings we talked about.
So you have the blueprint. You speak the language. Now let's lay out the full journey, the path from total beginner to, well, God level.
This is the path. This is how you do it. You start at stage 1 with the absolute basics, Python and some math. Then you build your machine learning foundations. Stage 3, you dive into deep learning. Stage 4 is where you master transformers and LLMs. This is crucial. Stage 5 is the fun part. You build your own model on your own data. 6 is learning how to make it fast, efficient, and ready for the real world. And stage 7, that's domination. That's when you're building custom, high-impact AI that solves real problems.
The most important thing to see here is that this isn't some impossible mountain you have to climb. It's a clear, 7-stage journey. And guess what? You now have the map.
And that really is the bottom line, isn't it? You have the blueprint for how AI models are built. You have the language to understand the conversation. And you have the roadmap to guide you on your own journey. You're officially equipped.
So, there's really only one question left to ask. With all this knowledge, with all this power at your fingertips, what are you going to build first?